Hello everyone, myself Shreyans Kishore, student of MCA DVV Indore. Today here I explain my assignment of theory of computation guidance under the Saligram Prajapati. Let's start. Consider the case of grammar that generates a subset of English. This subset of English is defined using a list of rules that describe how a valid sentence can be produced. We specified some rules. A sentence is made up of a noun phrase followed by a verb phrase. A noun phrase is made up of an article followed by an adjective followed by a noun. And the rest of the rules are like that. Move forward. From the rules, we can form a valid sentences using a series of replacement until no more rules can be used. For instance, we can follow the sequence of replacements. Now see the sentences are like that. Noun phrase, verb phrase, article, adjective, noun, verb phrase, article, adjective, noun, verb, adverb. The adjective, noun, verb, adverb. The large noun, verb, adverb. And the rest of the sentences are like that. Also, we can see that the quickly eats programmer is not a valid sentence. Here, refer to the grammar with the start symbol, sentence, set of terminals, the sleepy, happy, tortoise, hare, phases, run, quickly, slowly. And the set of non-terminals are like that. Noun phrase, transitive verb phrase, intransitive verb phrase, article, adjective, noun, verb, adverb. The production. Sentences, noun phrase, transitive verb phrase, noun phrase, sentence, noun phrase, intransitive verb phrase, noun phrase, article, adjective, and many more like that. Now we have the first question. Use the set of productions to show that each these sentences is a valid sentence. First, the happy hare runs. Second, the sleepy tortoise runs quickly. Third, the tortoise faces the hare. Fourth one, the sleepy hare passes the happy tortoise. Now solve the first one. The happy hare runs. Sentence are noun phrase, intransitive verb phrase, article, adjective, noun, transitive verb phrase, article, adjective, noun, transitive verb phrase. After three steps, we have the happy runs. Now the second one, the sleepy tortoise runs quickly. Sentence are noun phrase, intransitive verb phrase, article, adjective, noun, intransitive verb phrase, article, adjective, noun, intransitive adverb. After the four steps, the sleepy tortoise runs quickly. Now third one, the tortoise passes the hare. The sentence are noun phrase, transitive verb phrase, noun phrase, article, noun, transitive verb phrase, noun phrase, article, noun, transitive verb, noun phrase, article, noun, transitive verb, article, nouns. After fourth step, we got the tortoise passes the hare. Now the fourth one, the sleepy hare passes the happy tortoise. Sentence are noun phrase, transitive verb phrase, noun phrase, article, adjective, noun, transitive verb phrase, and noun phrase. Article, adjective, noun, transitive verb, noun phrase. Article, adjective, noun, transitive verb, article, adjective, noun. After the sixth step, we got the sleepy hare passes the happy tortoise. Now we have a second question. Construct the derivation tree for the sentences in question. The happy hare runs. The construction of derivation tree of this sentences have two parts: noun phrase and the intransitive verb phrase. Noun phrase having article, adjective, noun. Article having the, adjective having happy, noun having hare, and the intransitive verb phrase having intransitive verb and the runs. Now the third question. Construct a phrase structure grammar that generates all signed decimal numbers consisting of a sign either plus or minus, a non-negative integer, and a decimal fraction that is either an empty string or a decimal point followed by a positive integer, where initialize zero integer are followed. The code are like that. The constructive derivation trees of the tortoise phases the here. The sentences have three parts: noun phrase, intransitive verb phrase, noun phrase. The noun phrase having the article and the article having the, and the other one is noun having tortoise. The intransitive verb phrase having the transitive verb, transitive verb having passes. Noun phrase having the article and noun, and the articles the and here. The sleepy tortoise runs quickly. This sentence derivation trees sentences sentence having noun phrase intransitive verb phrase. Noun phrase having article, adjective, noun, and intransitive verb phrase having intransitive verb and verb adverb. Article having the, adjective having the sleepy, noun having tortoise, intransitive verb having run, adverb having quickly. Positive integer having integer, non-zero digit integer. Positive integer, non-zero digit having I equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. The second one, give the Baker's horn of this grammar. Sign decimal number, sign integer, positive integer, sign plus or minus. Integer equals to digit, integer digit, digit equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Non-zero digit equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive integer equals to integer and non-zero digit. Non-zero digit integer, non-zero integer, non-zero digit. Derivative tree of sign integer is sign and integer, sign having only sign and integer having digit and integer, and integer having digit and integer, so like that. And the other tree is sign decimal integer having sign, integer and integer positive, and also have a decimal. Integer having integer and digit, sign having sign, and a positive integer having non-zero digit. Now the other question, give production rule in Baker's norm form for an identifier if it is can consist of. First is no one more at least 3 but no more than 6 lowercase letters, 1 to 6 uppercase or lowercase letter beginning with an uppercase letter, a lowercase letter followed by a digit or an underscore followed by 3 or 4 alphanumerical character. First one, identifier equals to IC letter, identifier IC letter, IC letter equals to ABC Z, identifier equals to IC letter, IC letter, IC letter, IC letter, and continue so on. And the IC letter having the ABC and up to the Z. Same Baker's NOR code for this C1, Baker's NOR code for the D1. We having a not several extension of Baker's NOR from are commonly used to define phrase structure grammar. In one such extension, a question mark indicates there is a symbol of gra sorry symbol or group of symbols inside parentheses. To its left can appear 0 or ones, and asterisk indicates the symbol of left can appear 0 more times, and the plus indicates the symbol of left appear one more times. These extensions are part of the extend Baker's norm from EBNF, and the symbol question mark, uh, asterisk, and the plus are called meta character. In EBNF, the brackets used to denote non-terminal are usually not shown. Fourth question, give production rule in Baker's norm from that generational sorry generates all identifier in the C programming language. In can identifier starts with a letter or underscore. that is followed by one or more lowercase letter, uppercase letter, underscore, and a digit. Identifier having letters identifier symbols and the Baker-Snor code for this question. Another question: give production rule in extend Baker-Snor form that generates all decimal number consisting of an optional sign, a non-negative integer, and the decimal fraction that is either the empty string or a decimal point, followed by an optional positive integer. Optional proceed by some number of zeros. Answer is the Baker's NOR code for this question. The sixth question: give the production rule in the extend Baker's NOR form and the identifier in the C programming language. The production rule of C programming language is like that: digit having 0, 1, 2 up to 9, uppercase letter having A, B, C up to Z, lowercase letter having A, B, C up to Z, and so on. Now the seventh question: for each of these strings, determine whether it is generated by the grammar given for postfix notation. It is find the step used to generate the string. ABC strings plus second one is xy plus xy minus z strings. D is yxyz minus strings slash e is ade minus strings. Answer is answer of ABC star plus is because NOR code is expression term and operator and so on. For the second one is not generated. For the code is third one, and the code for fourth one is expression term factor and so on. For code for the fifth one, AD minus star is like that. We have in the eighth question: use Baker's norm form to describe the syntax of expression in infix notation, where the set of operators and identifier is the same as in the BNF for postfix expression, but parentheses must surrounded expansion being used as a factor. For each of these strings, determine whether it is generated by the grammar or infinite expression by it is or not. If it is, find the steps used to generate these strings. First is x plus y plus z. Second one is a divided by b plus c divided by c. C is third one is m star n plus p. Fourth one is like that, and other is like that. For the first one is not generated, and the third one because nor code is like that. For the third one is like that, and the fourth one is not generated. For the fifth one, m plus n star p minus q having this code, and this on. Now we have solved the internal question of theory of computation. The question is construct FA to accept the set of all string over 01 ending with the 01, and the solution for this question like that. We having a graph and the points are q0, q0, q1, q2, q3 and q4. The solution are like that. Now the second question is construct a PDA to accept the set L of string over 01 ending with 010. We having the solution. A PDA is a PDA ID identify as a omega slash and so on q0z0f, and the apply this some rules are on the code and we solve the question. Another question is construct FA to accept the set of all strings over 01 ending with 010. Answer is like that. We having this graph and we have points are q0, q1, q2, q3, q4, q5, and the solution are like that. We have the question is construct the TM that accept the language of 0 1 star plus 0 1 star. The answer is like that. We have in the same graph. We having a point Q0, Q1, Q2, Q3, Q4, Q6, Q5, and other is having the number of like that. We have in the last question. Construct a PDA equivalent to the following CFG: S equivalent to the 0 BB, B equivalent to 0 S, first S and 0. Test whether 0 1 to the power 4 is an null. Now the answer is we having the some states Q0, Q1, Q2, Q3 and Q4. Q1 is initial state, Q1 is state for handling 0 production, Q2 is state for handling first production, Q3 for state for handling the second 0 in the string, Q4 is accepting state. Now the testing the string 0 1 0 to the power 4 initial configuration Q0 0 1 0 4 and the so on. Apply transition rule based on the input string. We have this code Q0 0104Z, Q1 104, Q0, Q1 having 0400Z, Q1 4000Z, Q2 Q3 400Z, Q3 40Z, Q2 40Z, Q2 41Z, Q2 4Z, Q4 and belongs to the accepted. The string 0110 to the power 4 is expected by the PDA. The transition rules are like that: initial the state 0, move the state Q1 and trending 0, move to the state Q2 reading 1 and so on so on so on. Thank you for watching this video.